for tuning in to Remoticon. I know it's a little bit different than we've ever done anything before, but I think it's gone pretty well so far. And I like the fact that we're actually getting people in from all over the world. I think we heard somebody from Brazil before, so that's nice. This is the introduction to modular synthesis using VCV Rack with Jonathan Foote. I'm Dan Maloney. I'm a staff writer here at Hackaday. I'm going to be the MC, moderator, kind of person for this period. As far as Jonathan goes, his bio here says he's a recovering scientist, which I can relate to, being one myself. Lapsed musician, which I can't relate to because I don't have any musical talent whatsoever, and an electrical engineer from San Francisco. Understanding the principles of analog synthesis helped him study for his Ph.D. in signals analysis. One of his qualifications for running this workshop is that he has played analog synthesizers in front of paying audiences. So he's got us all beat most likely. So everybody welcome Jonathan Foote, and we'll get on with the show.
Hi, everybody. I'm John. Thanks for coming. I'm really stoked you could join me here. Couple things before we start. First of all, no pressure, but if you want to share your video just to see everybody who's here, the Hackaday people have made this nice community, and it's been so tough in this quarantine just to feel like you're with other people. So here we are with other people. And a big thanks to Dan, and a big thanks to Sophie and the Hackaday team, everybody, for putting us all together in the same place. Another couple things. I'm coming to you from San Francisco, and my neighbors are very keen on fireworks. So as the sun goes down, we might hear some explosions in the distance. That's totally normal and probably to be expected. And also, I know it's been a long week for a lot of us. If for any reason you're not following it, I'm talking too much, it's not interesting, it's not boring, you have a party to go to, maybe you're just burned out and need a nap, you can peace out at any time, there's zero shame, okay? A lot of this is pretty technical, and I realize if you're just kind of out of brain cells for the moment. If there are questions, you can ask them in the chat. I've dropped a couple things in the chat. I'm going to be driving this thing called VCV Rack. You can download it, you can follow along, or you can just watch me. I don't know what's going to be easier or less taxing or more fun. Maybe if you understand the principles, you don't even need me. Like, as long as you understand there's VCV Rack, you can download it and play with it. And there are probably some tutorials on YouTube that are better than me. So it's all good. All right. With that, let's get started, okay? I'm just gonna share my screen with VCV Rack. I'm gonna make sure we can all hear the noises that are going on. I have a couple slides I'm gonna be bouncing to back and forth, but mostly we're gonna see VCV Rack. Okay, let me see if I can play the button, push the buttons here. First thing you need to know is you need to select an audio output, and you do that through this menu here on the right. Let me zoom out. Control so you can see all the way on the right here, or almost on the way on the right, is the audio output, and you need to select your devices. And here I'm using my speakers. Okay, all right. So if you've got VCV running, and it is now using the keyboard on my laptop or on your laptop or on your system as a musical keyboard, if you press Z, you should get a note. Okay, so that's the basics. That's kind of how it works. We're going to learn about what all these little knobs and switches and these wires do. All right, so this is a way of generating music that's called subtractive synthesis. And let me just switch to a slide for a second here. Okay. All right, so I think we're all kind of got an engineering bent, or maybe a little kind of technical, have our technical hat on. So this is kind of a block diagram of what we're seeing. or will be seeing in the VCV rack. Okay, we have a keyboard which generates a control voltage. The control voltage, and I apologize for all the acronym salad, but that's just how this thing is. This is how it works. VCO stands for voltage controlled oscillator, and this generates a tone that you operate on with the filter, which is also voltage controlled, so it's called a voltage controlled filter. And then this goes into a voltage controlled amplifier, which can make it louder or softer. And all these things are controlled by control voltages, which are generated by different things like a low frequency oscillator. This generates a control voltage to control the audio oscillator. And these are envelope generators, also called ADSRs, for attack, decay, sustain, and release. And we'll talk about all these one at a time. So let's start with a voltage controlled oscillator. And so I'm going to switch back. Okay, and so you can see corresponding to that block diagram, we have the voltage controlled oscillator, the VCO here, and this is going into a voltage controlled frequency, voltage controlled filter. The output of that goes into an amplifier in the mixer, and the output of that goes to your speakers or to your audio device or your headphones so you can hear them. Okay, so let's zoom in on the voltage controlled oscillator. Okay, let me see. Okay, so this has a number of knobs and dials to the big knob, and need to apologize here in that this program, when I'm adjusting a knob, the pointer disappears, so it's not obvious what I'm doing. So I'm going to try and make it very obvious what I'm poking at when I poke at it. So right now, I'm just going to play a note, and I'm going to change this frequency knob, and you can hear how this changes the frequency. Turn it up, turn it down, but we'll just let it sit in the middle there. And here's a fine frequency adjustment, does the same thing, but this is good for tuning. Once again, I'm adjusting the fine knob here. All right, and these things here, these are now wires. These are patch cords. In the old days, these are exactly like analog synthesizer patch cords, except analog synthesizer patch cords, every problem you've ever had with your headphone patch cords, you can have these multiplied by the number of patch cords you have. They go bad, they go wonky, sometimes they don't work, sometimes they don't plug all the way in. But here, and when you're doing analog synthesizer, you almost always run out of patch cords. But here, these are infinite, and these are they're perfect. They never go bad. They always work. So these are jacks on the bottom here, these round double circles here. The white ones are input jacks, and voltages go into them, and the black ones are output jacks. And you can't, this won't let you connect two outputs together, because usually nothing good happens with that on an analog synthesizer. That's not the case. You can definitely plug two outputs together, and that's not recommended. I should say that if you're interested in analog synthesizers, this is a great way to get started with this program. If you're interested in Eurorack synthesizers in particular, a lot of Eurorack manufacturers make software versions of their modules that you can drop into this and experiment with. Okay, so I should mention that these are all kind of modules that are all kind of standalone things, and you can mix and you can match them, and you can plug and you can unplug them. Right now, this is the output of the voltage controlled oscillator, the oscillator going to the input of the filter. So this is just this thing, this patch cord right here, and you can grab it and I can unplug it. And if I unplug it, nothing happens if I play a note. There's no sound coming out because we have not taken the output, we've broken this. So when you're doing this, it's very easy to get to a point where nothing's working, no sounds are coming out, not the sounds you wanted to are coming out. So you do have to spend a little bit of time with your debugging hat on. If you're a computer programmer or you're an electrical engineer, you're used to working like this with your debugging hat on. If you're not, that may take a little getting used to. But here's a pro tip, at least during the workshop. If you ever get stuck and things aren't working like you want to, you can basically pull the ripcord, go up to the file menu, say new, and this will just regenerate that basic patch that it started with. And that will make sure that you undo any changes that you made. All right, so let's hook up that patch cord again. So click on the sawtooth and can just drag it to the input of the filter. And that's now connected again. So hopefully when I press a key, I'm going to press the Z, we have a note here. And a couple switches here. This is analog, digital. The digital gives you a little cleaner digital looking waveform. What's really cool is that this is hooked up to the oscilloscope here so we can see the waveform. And you can see the frequency change. The peaks of the waveform will get closer together if we increase the frequency. If I hit Q, that's an octave up. So that is double the number of waves per time. So that's twice the frequency. All right. So if I wanted just to get a little vibrato in here, I could just play and I could take this fine thing and I could just wobble that. And just get a little vibrato going in there. Okay, but let me introduce you to the beauty of control voltages. And this is Bob Moog's basic innovation, realizes that anything that you can turn with a knob, you can turn with a control voltage. And a lot of all these modules create control voltages. So let's add a what's called a low frequency oscillator. And this is a little module that gives you a changing voltage output, which we can use to control the voltage controlled oscillator. So we can use it to control the frequency of that to give it a little vibrato. Okay. So I'm going to zoom out and I'm going to show you how to add a module. What you do is you right click and this gives you I'm going to do this, it's going to give you a big menu of all the possible modules that you can add. Now these are the stock modules. If you go to VCV Rack and you make an account, there's hundreds, if not thousands of other modules, including custom modules, including modules that look like other people's hardware Eurorack modules that you can actually spend money on and buy the hardware and hook them together. Okay, so I'm going to add a voltage controlled oscillator, which is the low frequency oscillator, which is here kind of in the middle of the top thing. So I'm just going to click on that. And that's put it down on the bottom of the rack because I'm zoomed out here. All right. Okay, so this has a number of control knobs too. And the voltage controlled oscillator is primarily for audio, range signals, and the low frequency oscillator is for lower frequency. You can see how fast it's going. It's blinking this pseudo LED by how fast it's going. And it's also got a frequency knob. I can turn it up and you can see that's blinking faster or make it slower. Okay, so what I'm going to do now is I'm going to patch this so the low frequency oscillator is controlling the frequency of the VCO. And it's got an input here called FM for frequency modulation. So I'm going to take the sine wave output of this. I'm going to use the square wave. SQR stands for square wave output, and I'm going to hook that up to the frequency modulation input. Okay, and now when I hold down a key, nothing's going to happen until I turn up this knob, which patches this control voltage input to the actual frequency generation stuff. So if I'm going to give that a little bit of a goose there, take it off 7 or 8 o'clock where it was, and you can hear this now changing the frequency, and it's doing it at a square wave, so it's doing it in discrete 1-0 increments. Now I can increase this and get a larger change of frequency. All right, that's a good European siren sound right there. And I can also change the frequency of the low frequency oscillator using this knob down here. So you can just hear what that sounds like. Faster, slower. All right. So this is the fundamentals of voltage control synthesis, where you can use all these modules and a whole bunch of them, and you can use the output of a audio frequency oscillator to modulate the frequency of another audio frequency oscillator, and that is that gives you some really interesting frequency modulation sounds. For instance, I'm now going to change this. Actually, before I do that, I'm just going to turn that. I'm going to look at the various outputs of our voltage controlled oscillator. So right now, this is a Sawtooth, and you can see on the scope here. And let me zoom in a little bit. Is this okay? People seeing things? Is this too fast, too slow? People still with me? And once again, if this is boring or too much of me yakking, feel free to peace out at any time.
I think it looks good so far.
Okay, good, good. And we'll take a break in about 45 minutes, and I'll take a couple little breaks. So if people are just playing along, you can twiddle some of the knobs and just see how that works.
Hey, Jonathan.
Yes, sir.
Someone is just asking about VCV on a rack. I'm sorry, on a VCV rack on a Mac with all the default settings was just installed. I can see the oscillator moving, but when I push keyboard buttons, but there's no sound coming out. Okay, I can't not diagnose everything, but one of the things you might need to do is check your audio output. And there's a menu here. It's going to be different on a Mac because this is a Mac, but I'm running Windows, boo hiss. There's a menu here which says which audio device you want output. And hopefully that will do the right thing on the Macintosh. And if there are any Mac enthusiasts that can help with some advice on the chat, that'd be great. Looks like people are pitching in on the chat, so I think we'll be good. Awesome, thank you. That was it, thanks, yep. Great, great. Oh, hey, somebody's actually paying attention. All right, so if you're joining us late, thank you for joining the workshop here. A lot of material. I realize it's been a long week, and thank you. I hope this is fun and cool, and I'm stoked to share this with you. All right, so let's go back to the oscillator because that has a number of outputs. It has 4 of these outputs here. The Sawtooth, you can play a note, look it on the scope, and guess why that's called a Sawtooth. All right, let's change. I'm going to unplug the Sawtooth here and plug in the square wave. Maybe zoom in a little bit so you can see that. And play a note, and hey, that's a square wave. And note how it sounds different. It has a different timbre from the Sawtooth. Let's go back to the Sawtooth and go to the square wave. Okay, now here's a fun thing you can do, which is 2 more of these knobs on the voltage controlled oscillator. You can change the pulse width of the square wave. If you're an engineer, this is pulse width modulation, and you can change the duty cycle, and the scope makes it pretty clear what's happening when we twiddle this knob. So let's change the pulse width and see what happens. So that really changes the harmonic content of the notes we're getting from the oscillator. And it's really good to have a lot of harmonic content. You can have the sine wave output. Typically that's not used very much because that just gives you a sine wave. And that doesn't do much in the filter or any of the upstream stuff. It's a very, very pure note. To actually get some nice synthesizer sounds, you want to start with a harmonically rich content like the Sawtooth or the square wave, or you take that square wave all the way down, make it narrow, make a pulse. Okay. Those all sound different because they have different harmonic content. Yeah, let me just switch quickly to a slide. I have a couple slides that illustrate a couple of the principles here.
Give me a second here. Okay. All right. Hopefully people can see this, this diagram. Okay, we're using subtractive synthesis, and the way that works is you start with a harmonically rich waveform like we're getting out of the voltage controlled oscillator, the VCO, and you put that into a filter, and that removes or accentuates some of the harmonics, and then that gives you kind of a richer, more interesting frequency output. And a lot of instruments in the human voice work this way. The human voice, you start with this kind of very buzzy signal from your vocal cords. People can put tiny microphones down your vocal tract while you're speaking, and it's kind of this terrifying Darth Vader buzzy sound. And then what that happens is that gets filtered by your vocal tract, which has the resonant cavities in your mouth and your nose, and it smooths off some of the buzziness and gives the characteristic vowels, the ahs and the e's, and then the final output is your speaking voice or vowels. And a lot of acoustic instruments work the same way too. You start with an excitation voltage and a brass instrument that's your kind of buzzing your lips, or a clarinet, it's a reed, and it goes through a resonant cavity like the body of a violin or the body of a guitar, which kind of shapes this this initial excitation waveform, and it smooths it out and accentuates some frequency and filters out some others. So you get a more interesting, more musically valid output. And a really great way to think about this is in the frequency domain. So you start with with an excitation signal that has a lot of high frequency components. If it's a square wave, it looks like this, I think 1 over f squared. I can't remember, but in school at some point they made me calculate the Fourier transform of a sawtooth wave, and you got all these nice harmonics. And what you do is you put that into the filter, and that's our voltage controlled filter, which we'll be talking about really soon. And that will filters out some of the harmonics or lets you accentuate some other harmonics. And that gives you kind of a more interesting, musically valid sound on the output. All right, just to remind everybody of Jean-Baptiste Fourier in 1740 whatever, proved that you can make a square wave just by adding up a bunch of sine waves. And you can do the same thing with a sawtooth or something. Here's a square wave, and you add up a whole bunch of sinusoids, and the more sinusoids you add, the more it looks like a square wave. And these are the amplitudes of the sine waves. Notice there's no even harmonics, just the odd ones. And if you do the math of the actual Fourier transform, that's what you get. And so these are harmonics. These are musicians sometimes call them partial. If you play a guitar, you know you can pick a harmonic out on the string just by putting your finger on the middle fret and damping out the fundamental. So these are our marble that we're going to chip into a beautiful musical sculpture using the filter. So it's good to start out with a very rich harmonic content. And here's some harmonic content of the various things we can get from our voltage controlled oscillator. You can get the sine wave, and that's a little boring because that doesn't have any high frequencies there. That's just got the pure fundamental. The square wave has the odd harmonics. The triangular wave has odd harmonics, but they go down quicker. The sawtooth wave has lots of juicy harmonics, and if you make a pulse wave, it has even more harmonics. And those change depending on the pulse width of your pulse. So let's go back to our VCV rack, and you can hear how these things are different. So once again, here's a square wave, and this sounds to my ears, you can kind of imagine it's like a clarinet. The clarinet has the reed, it's either on or off. It gives you this kind of, the reed is either open or closed. It gives you this thing. And if you go back to the sawtooth, it gives you a little brassier sound. Buzz, buzz, buzz. Okay, so now we're about ready. Oh yeah, before I forget, one more thing. and this is a little pro tip. Remember how I could use the low frequency oscillator? Let me zoom out a little bit. If I turn up the control voltage to get a little, let me turn up the frequency here too, to get a little vibrato here. Yeah, let me change this now to a triangle wave. All right, maybe that's a little too much. I'm going to take down the modulation, the frequency modulation a little bit, and I'm going to bring up the frequency a little bit. So that's a little bit of vibrato. You can imagine an opera singer doing that, or if you're playing the theremin, you wobble your fist near the antenna to get a little bit of frequency modulation. But let's do some pulse width modulation, okay? So I'm gonna unplug the frequency modulation. I'm gonna plug this into the pulse width modulation. And once again, this knob now controls how much this oscillator is controlling the pulse width. I'm gonna turn it down so you can hear what it's doing. Oh, I need to turn this up, whoops. Oh, yes, I also need to listen to the square wave, which is the actual pulse wave. So you can see how that's changing with time. And that gives you a kind of a nice, time varying, a little richer tone. Here's a pro tip. If we turn up the frequency a lot, we get these inharmonic stuff. This is kind of the rave Hoover sound. So if you want to be Darude, so that's a classic electro rave Hoover sound, which is pulse width modulation at a pretty high frequency. How are we doing on time? Okay, it's been half an hour. Let's take just a short break and people can play around with things. And when we come back in like just 2 or 3 minutes, super short, we will do the filter. And that's kind of where the magic happens of the synthesizer. But feel free to plug and patch and twiddle some knobs. Okay, so back in like 3 minutes. And that'll give me a chance to also check the comments.
We have a request to zoom out a little bit to show
Oh,
the
yes,
whole patch.
absolutely.
Yeah, if you could favor a little bit to the left, because a lot of us have the gallery view sort of on the right there, and it's blocking things. How close to a hardware setup is this going to look?
If you can, I'm not sure you can buy this actual hardware, but this is very similar. If you buy a mini Moog or a lot of Eurorack things will work very, very similarly. So
I think that's the most important thing I've learned so far is the correct pronunciation of Moog.
All right.
I've always assumed it was just Moog.
Yeah, I think it's Moog. I think it's Moog.
I think you're right, yeah.
Okay, so a little sidebar here. So in order to get a richer sound, you can stack these oscillators, and because if they're analog oscillators, they're never at precisely the exact frequency. You can get a little bit of richer sound by adding in a couple oscillators. And Wendy Carlos for Switched on Box, she used 6 of the Moog voltage controlled oscillators. There's a guy on YouTube who hooked up 1,000 of them, and it sounds pretty dope, as you might imagine. It sounds very, very fat. But if you're not used to analog synthesizers, you only get one note at a time. Without a little bit of reverb or a little bit of delay, and I'll show you how to hook that up, it can sound a little bit thin. So, all this stuff you need to understand that this is a musical instrument and takes a little practice and understanding to get to know how to use. So hopefully I can give you the pointers to get some sounds out of it, but to be a Paganini, you'll take some practice. All right, let's move on to the filter. And the filter is kind of where the magic happens. And this is how you get some of those very, very classic synthesizer sounds. And what the filter does is, you might imagine by the name, it's filtering out harmonics. It's a frequency dependent filter that lets some frequencies through and cuts some frequencies out. And this big knob changes the frequency. And right now it's set all the way down because it's being controlled by this thing called the envelope generator, which we'll talk about in a couple minutes. Okay, right now, I'm going to take down the control voltage. So I'm going to basically remove the influence of the envelope generator, and this will just let me play with the filter by itself. Okay, so I think that will do it. Now, if I play something, you won't hear anything, and that's because the filter is all the way down. It's filtered out all the frequencies. But if I can turn it up, might be able to see something. Yeah, you can see something on the scope. Oh yeah, let me turn down this annoying pulse width modulation. I just did that. So goodbye, Rave Hoover. And as you turn up the frequency, you hear more and more high frequencies, so it gets brighter and crisper. And this is the kind of classic synth sound, which is a filter sweep. Okay, so I'm just dragging this. I'm just turning this knob manually. But once again, we can use a low frequency oscillator. I'm going to take the unplug it from the PWM, and this is the frequency control input. I'm going to unplug the envelope generator for now. Remind me I need to plug that back in again. Okay, and I'm going to plug our low frequency oscillator into the voltage controlled frequency. So now, let me just go down, and this is the triangle wave output. So you can hear, I need to turn this up a little bit. Let me also turn down the frequency here. So now you can hear how the filter is changing over time. And we can make that higher for a brighter sound, or we can make it lower for a kind of warmer, duller sound. And we can make it so low, we filter out all the sound completely. It's just gone, it's quiet. Okay, so that's a low pass filter. This is the one you usually use because you usually want the fundamental, but there's also a high pass filter. So let's listen to that. And this will be a lot brighter because this is only letting the high frequencies through. And that's kind of cool. And if we turn this all the way down, it's a high pass filter. So now I apologize if that's too loud. Let me take that down here a little bit on the mixer. Now this is super bright, super zingy, super electric. And as we turn this up the high pass filter, we're removing more and more low frequencies, so we'll get even buzzier until all we're left is just the high harmonics, just those crispy edges of the high harmonics of this pulse width. Let me turn up the pulse width here. Okay, so that's the high pass filter. Let me go back to the low pass filter and do it here. Okay, so this is kind of where the magic happens of those classic analog synthesizer sounds is in the voltage controlled filter. And there's one more magic thing here, which is called the resonance. And if you're an electrical engineer, you've seen this as the Q factor of a filter. And let me just show you what happens when you turn this up. What this does is this accentuates the peak around the filter cutoff, and this lets you basically not only cut out particular frequencies, it lets you boost them too. So I'm going to turn this up and you can hear it. Okay, let me turn up the volume here a little bit too.
John, one quick question.
Yes, sir.
The green cable on the VFC or the VCF, is that connected to the triangle or to the square wave output of the LFO?
Right now it's connected to the triangle.
Triangle. Okay, thank you. Someone had a question on that.
Yeah, that's a good one. That's a good one. Okay, so, and if you turn it up high enough, it's going to whistle. It'll resonate. And I'm going to turn the volume down because that can be really shrieking and very loud because this thing is not coming out of the oscillator. This thing is coming out of the filter. Okay, so if you hear that whistling, that is the filter. That whistling is the filter itself oscillating. Okay, let me quickly just show you a picture of what's going on in the frequency domain because that might make it a little bit clearer. Okay, remember this is our raw materials, these high frequencies and their partials. This is what the filter does. You basically multiply it by this, and this is different amounts that you've turned up the resonance. If it's got a low resonance, it's got a very normal shoulder, it's got a very flat response. If you turn up that resonance, you get a little bit more peak at the center frequency. So the resonance, the Q knob is changing how peaky the filter is, and the big filter knob, the big knob in the center is changing where the center frequency is in the frequency domain here. Whoops, I didn't mean to scroll, but that kind of illustrated it. So those give you two things. And if you have the resonant frequency turned up enough, it more or less looks like a bandpass filter because the low frequencies here are the high frequencies here are gone. The low frequencies here are not boosted, but the center frequencies are boosted a lot. So this is essentially a bandpass filter, and you can turn that up so it only the things in this bandpass are what you hear. So let's go back to the rack, and this is really interesting because you can use this as a. I'm going to turn down the control voltage here. Actually, I'm just going to unplug that completely. So now we've got pretty high resonance. And what you should be able to do is pick out the higher frequencies just by changing our frequency here. So let me see if I can do that. Yeah, let me turn it up a little bit. So there. So that's the first harmonic. You can hear it's an octave. And then you go up the harmonic sequence, the harmonic series, which is twice the fundamental, that's an octave, 3 times the fundamental, that's an octave and a fifth, 4 times the fundamental, that's an octave, a fifth and a third, and so forth and so on. And really interestingly, pretty quickly it gets out of the 12-tone scale. So if you want some microtones to play with, you can get them out of the harmonic series, and they're all fundamentally harmonically related to the fundamental, which is that pitch that you're hearing. Okay, so I think that's really cool. That's a really kind of natural way to understand the harmonic series, where you can actually pick them out using the bandpass filter to kind of zero in on them. But let's push on. Let's talk about the envelope generator. Okay, so all these things have been kind of constant. If things have been changing with time, they've been changing using these oscillators, which just go back and forth. So let's talk about the envelope generator too, and that's called ADSR here, and that's for attack, decay, sustain, and release. So let's zoom out and look a little bit at the big picture now. Okay, so in here on the far left here, this is the MIDI/control voltage thing. This is generating from the keyboard. It's generating a control voltage, which controls the pitch of the oscillator. This is also generating a trigger and a gate. These are basically digital signals, and some synthesizers, they're just TTL, they're on-off signals. The gate is high when you have a key pressed down, and when you release the key, the gate goes off. So it's high when the key is down, and it's low when the key is up. And you can hook that into the scope and watch that if you want to, but I think I'll just have you take my word for it right now. But right now, that gate is plugged into the ADSR, and the trigger, the RTRG, this gives you a pulse every time a key is pressed. And so the gate tells you when a key is down, and the retrigger gives you a pulse every time a key is pressed. And what the ADSR, this is a little sequencer. This is a little finite state machine if you're an engineer, and it's triggered by this trigger signal. Every time you press the key down, it steps through these 4 steps: attack, decay, sustain, release. All right, so if I press the button, press a key, you should see it just walk right through. Let me make things a little slower. Okay, so this is a little weird. It goes attack, decay, sustain, release. Attack and decay are times. They are durations. Release is a duration. The one odd person out here is sustain. This is a level. Yeah, let me see if I can actually plug this into the scope, and I'll scooch over here so hopefully people can see this. And let's take the output of the ADSR. Now this is generated control voltage output, not an audio output. So if you want to patch 2 things from the same output, you hit control. So I'm going to hit control on the output and patch that into the X. And I think I need to take down the time base of the scope. Now, unfortunately, this doesn't work like a trigger as you'd expect if you're used to oscilloscopes. So you just got to get lucky to catch it. So we'll see here. Okay, good, I got it. So what's happening is it has a long attack, it has a long decay, the sustain is a level, and it has a long release because all these knobs are up. If I turn down the attack to very short, let me see if I can catch it. You can see it, that attack is really short. Let me turn down the time base here. Okay, if I increase the attack here, you can see how it's slower on the attack. Let me catch it. There we go. And you can make it really slow so it kind of swoops up. And you make it even slower so it really slowly swoops up. All right. And the decay is how quickly it comes down after it hits the peak. So I'm going to turn down the attack all the way so it's a quick attack. And here we got a long decay. Let's make a short decay. I got to catch it. There we go. So you can see it comes down quickly after it hits that peak. Or we can give it a long decay, which means it'll come down slower. There we go. All right. Now, like I said, this third one is, actually what's nice about this particular envelope generator is that you can see what stage you're in by these little indicator lights. So if I make everything slow, you can actually, and you hit a key, you can see it walk through the various stages. Attack, decay, sustain, release. Now, sustain is the level that it will hold while I'm holding down the key. So if I turn this all the way down and I hold down the key, all you hear is the attack and the decay. So I'm going to make them both pretty short. Whoops, too short. So this is good for like plucked strings where you don't have a lot of decay. But if you want an organ sound, if you want a brass sound, you want a little bit more sustain to hold that note while you're holding the key down. And if you want to remove the decay completely, you just turn the sustain all the way up. And this is like a brass where it's loud and it doesn't really decay. All right, so if the sustain is all the way up, this is the level, then the decay doesn't matter. And the release is how long it lasts when you pick up the key. So if you want a nice bell tone, you can turn the sustain all the way down and turn up the release a little bit. This will give you a xylophone or a plucked string. If you turn it all the way up, you get bells. Whoops, I'm sorry. The release only releases the level that it was at the sustain. There we go. So that's a really long release. So if you want nice bell tones or marimbas or xylophones or gongs, you'll add in a little bit of release here. Okay, how are we doing on time? We're 45 minutes into it. Hopefully people are doing okay. At the hour mark or a little bit before the hour mark, we'll take a break. You can do a bio break. Hopefully people are sticking with this and this isn't going too fast. Break is in sight. Just a couple other things I want to show you before the break.
There is a question in the chat if you want to take a look at that.
Oh, yeah. Let me take a look at the chat. Where is the chat? Where did my chat go? There we go. Oh yes, go over trig and gate. Okay, couple questions here. Okay, question. Holding a key and pressing another doesn't reset the ADSR. Is that because all signals coming from MIDI CV count as on versus treating keys separately? I think that is the case. There is a VCV Rack will do some polyphony. In other words, it will do multiple notes from the MIDI input. I'm not sure how that works from the keyboard. A lot of computer keyboards are not set up for polyphony, so you can't tell when you have two keyboard keys down like QWERTY keys. So I think that's a little limitation just of the computer keyboards that you can't retrigger when you hit another key. But this retrigger thing will give you a pulse every time you hit a key. So the retrigger starts the sequence, and what the gate does is it tells you how long to sustain. So the gate will, as long as the gate is held high, you will be in sustain. So I just hit a key. Oop, I need to get back to my screen share here. There we go. So you can actually see how this works because of the little indicator lights. As long as I hold down a key, the gate light will be asserted, it will be lit, but I'll only get a little pulse from the retrigger. But every time you hit a key, another key, you'll see a little pulse on the retrigger. So hopefully that cleared that up. And so the envelope generator needs both signals. It uses the retrigger to know when to trigger the state machine that just walks through the attack, decay, sustain, release, and it needs to use the gate to know how long to hold the sustain for, to know when you're sustaining. When you release the key, the gate goes low, and then you're into the release part of the state machine. Okay.
Thanks.
Great. Okay, let me just show you two quick little tricks here. Control out. So if you're just noodling away with this, these sounds can be a little bit not compelling. If you're just playing along at home or something, I really recommend adding a delay or a reverb. It just makes the sound a little bit richer, a little bit more lifelike. And to show you how to add the delay, let's talk a little bit about a final module, which is the voltage controlled amplifier. Now, that's kind of hidden in this patch in the mixer. It's built into the mixer. And that's why the voltage controlled oscillator, it's oscillating all the time. The reason we can't, we're not hearing it all the time is because we have the envelope generator plugged into a voltage controlled amplifier that's built into the mixer. If I unplug it, I'm going to turn the volume down here on the mixer and maybe zoom into that a little bit. If I unplug that, the control voltage of this amplifier, then it's on all the time, right? And that's super annoying, which is why I didn't do that. Okay, so let's actually add in a module that's a voltage controlled amplifier, because that's a handy thing to have. Let me just move some stuff around here so there's room for it. And you can grab all these things and just move them around. So what I'm going to do is I'm going to right click. I'm going to add a VCA, a voltage controlled amplifier. I'm going to use the output of the envelope generator. And once again, control gives you another patch cord from an output. That goes to the control voltage input. The output of our low pass filter, instead of going into the mixer, that's going to go to the input of our voltage controlled amplifier. And now the output of our voltage controlled amplifier will go to the input of our mixer. And I need to remember to turn up the mixer again. Now this is just duplicating the little voltage controlled amplifier that's built into the mixer because you use it all the time. They kind of made that a normal part of the process here. So now hopefully, if I've done this right, we get our normal patch back. Okay, but now since we have this one wire contains all our audio, after the amplifier, we can now stick in some other things. So let's stick in a delay. All right, so someplace here is a delay. Yeah, right there on the top row is a delay. Okay, and so now I'm going to take the output of the voltage controlled amplifier. I'm going to put it into the delay. And I can take the output of the delay and put that back into our mixer so we can hear it. Okay, and this is the mix. This is the color, feedback, and time. If you've used the delay pedals on a guitar, you're used to this. And now let's play a note. And that gives us just a little bit more, more slap back. We can increase the time of the echo. And this is fun to play around with. You can do polyrhythmic stuff. Or you can make that shorter for a little slap back echo. Increase the feedback. Sounds a little bit more like a reverb, a little bit more like a room. The color rolls off the high frequencies, like if you're in a absorbent room. I'm not sure how easy that is to hear. And the final knob here is the mix. If you put that all the way wet, all you get is reverb. And if you put that all the way dry, all you get is the direct signal without any delay. So this lets you mix in how much delay you actually want. All right. Okay, let's take a little break. Let's take 5 minutes. I think I need to feed my cat. I will come back. I will get to some questions in the chat. In the next part of the workshop, we will do a little drum machine, and we'll play some more with triggers and gates, and we'll use the resonance of the voltage controlled filter, and we'll do a Kraftwerk snare and an 808 kick drum sound and put those all together with a sequencer. And that should be fun. But let's take a little break. And I'll be back in 5, and I'll check out the chat.
John, can you just zoom out again so people can see
Yes.
your patch if they
Thank
want to
Good, good, yeah.
replicate it? Thank you. All right, see everybody in a couple minutes.
And we're back. Hello, everybody. Thanks for sticking with this. I'm really stoked that everybody decided to join us for this. Thanks again to the Hackaday people for making a community. I hope this is interesting. At least some people stuck through it. And once again, I want to remind you that you're under no compunction to stick through this. I know on the East Coast, it's probably getting to be kind of party time, or maybe you're a little pooped from a long and stressful week for a lot of us. If you need to take a nap, there's absolutely, you can leave with my blessing. So anyway, let's move on. Okay, and thank you for all the comments in the chat. There are some great links. The Fourier visualization from 3 Blue 1 Brown, the Keith Whitman Fullerton's Eurorack setup, and you realize how nice it is to have virtual patch cords which are infinite and don't get on top of each other, so you can still see what's going on. So thanks everybody. Let me go back to our VCV Rack. Something I forgot to mention, this is all open source. I've been meaning to work on the scope and actually make the trigger like the scopes I'm used to. If you right click on any particular module, there's a plugin menu, and you can go to the source code. This will take you right to the GitHub repository for the source code for that module. So if you want to get into audio programming, this is not a bad way to do this, to see how some of these modules work, and they're kind of small and modular, so you only need to worry about one little bit of the whole thing at a time. Okay, let us start from scratch here. I'm just gonna go to File, and I'm gonna go New, and to start from scratch. I don't need to save this, so I'm going to say, okay, you might want to save yours. Okay, and I need to remember to reset the audio to my speakers so I can hear it. And we'll start from scratch here and just do a little bit of sanity checking. I'm just going to play a note. I can hear that. Hopefully you can. Okay, well, there's one more audio source that I didn't get to in our first half, and it's a noise source. And that turns out to be surprisingly musically useful. You don't think noise is actually that musical, but a lot of things have noisy components. A lot of percussion is not pitched. A lot of even pitched notes, like a calliope has a little kind of steam chuff when it's turning on, when the note on the onset of the note. So to get a little flute or calliope sound, sometimes you'll just mix in a little bit of white noise. So let's pull up a, hang on a sec, let me move things around here. Oop, wrong thing. Pardon me, my thing has gone off the screen, so I can't grab it. I'm sharing. All right, I'll just make do with what we got here. Thanks again to Dan for running interference on the questions. Don't have quite enough screen to have my chat and all the controls up, so I apologize if I'm missing things as they go by in the chat. There we go, got it. Okay, so let's add a noise source. I'm going to right click, and someplace is the noise. Here it is on the second column, almost all the way to the right. Let me see if I can do that over here. Nope, always comes up in the same place. So anyway, I'm just going to click on that. I'm going to grab that, and I'm going to put that down here. Okay, let me zoom in a little bit. Okay, so now what I'm going to do is, instead of the output of the voltage controlled oscillator going into our patch here, I'm going to disconnect that. I'm going to add the noise. It's just some white noise. And there's various flavors of noise: white, pink, red, green. And so you can hear what the filter is now doing to the noise. So that's kind of got a good sounds like wind through trees or something like that. In fact, if I take down the envelope generator, and I think 12 o'clock means that's not doing anything, you can hear what the filter does to the noise. Just by changing the filter cutoff frequency. So if you need spooky wind sounds for your science fiction, for your horror movie or something, this is a good way to get them. Or if you want to do a surf generator for those relaxing surf tones, you can do it using the noise. Now, the different colors of the noise are basically refer to the spectral content. Pink noise has a little less high frequency in analogy with light. Pink light has less blue and more red, more lower frequency spectrum, and so does the pink noise here. Let me turn the filter all the way up so you can hear that. That's white, pink, red. It just gets more and more filter. Violet is high frequency and low frequency, but not much middle. Blue is high frequency, very hissy. Gray and black are different probability distributions. I think black is a uniform distribution and white is a Gaussian. I forget what gray is. Okay, so white is pretty good for most audio things. You can also use the noise as control voltages if you ever want random inputs or make things a little bit more human or unpredictable, you can use the noise. All right, but one of the things I'm going to do now here is going to use the noise for a kind of a classic snare sound. And let me see if I can do this manually. If I hit the trigger and I sweep the filter, you can that's kind of a classic analog snare sound, like the TR-808 or something like that, or Kraftwerk. A lot of their snare sounds is basically just white noise that's gone through a filter sweep. So all I need to do that is to get the ADSR to use the envelope generator to generate a nice little sweep, just to go swoop right down. And we don't need any sustain, so we can do this all in the attack and the decay. So I need to remember to turn up the control voltage so the envelope generator is affecting the frequency of the filter. So I'm going to turn that up. I'm going to turn down the filter so we actually get a good sweep. And then now turn down the attack and turn down the decay here. There we go. So that's a little bit high. Let's turn up the frequency and maybe the resonance too, so it's a little bit more obvious what's going on. I'm going to turn down the sustain. So there we go. So that's actually not a bad electro snare sound. All right. Okay. Let's go over the gates and the triggers now. We don't necessarily have to trigger this by the keyboard. We can add a sequencer module. So let's do that right now, and we will trigger our snare from a sequencer. So I'm going to right click, and it's this Seek3, it's this big module on the second row with all the knobs and outputs. Okay, what this is this is a state machine. It's just walking, there are 8 states, or steps as they're called, You can change the number of steps using this knob here. Let me zoom into that so people can see that. You can change the number of steps using this knob here. The gate is, this is an output, is generating an output gate, and these are trigger outputs. When it's in a particular state, it will generate a trigger. And it's a little hard to see, but you can see it's a little brighter green when it's in that particular state. So it's just walking left to right. If you've ever used you ever built a Larson scanner from Evil Mad Scientist, or a LED sequencer, it's exactly the same thing. It's just stepping 1, 2, 3, 4, and then going right back. And that's run off this internal clock. You can use an external clock, but right now it's doing the internal clock. And this button, it's a button, you can start it and stop it using the button. So let's use this gate output to trigger our snare. So that snare is coming from, right now the trigger is coming from the keyboard. So let us unplug the trigger from our keyboard and plug it into the gate. Now this is just going to go bang, 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 bang. So I'm going to mute it quickly using the mixer, but let's see. Do I need to do a gate too? Yes, I need to. All right. Why aren't we hearing that? Let's just do the gate. There we go. All right, so I'm gonna mute that using the mixer just so it's not on all the time and it's not super annoying. I can also start it and stop it using the sequencer. So turning it back up, stop, and run stop, something like that. Okay, well, that's kind of annoying because that's giving us a snare hit on every beat. What if we want it on every other beat? Well, that's where we can use these trigger outputs down here. And to do that, I'm going to use another thing which will let us combine multiple triggers. These are all outputs. We can't all hook them up to the same gate. We need to mix them first or add them. So I'm going to add another module, which is, where did it go? Might need to scroll down. Oops. Where is the module I'm looking for? Here it is. It's called Unity. It's on the far left of the top row. Okay. And what this is just a dumb little mixer. It has a bunch of inputs and it combines them all into the same output. And you can average them all or you can sum them all. And for audio, you might want to use average. In this case, we're using it for trigger signals, so it doesn't really matter, but sum works just great. So what I'm going to do is I'm going to take the output of this and plug it into the gate. Let me go back up here. Once again, this is the gate that triggers the ADSR, which is triggering our filter, which is sweeping our noise. And now I can use individual outputs of the sequencer steps to trigger the snare. So here I can do it on, let's do it on beats 2 and 4. And I'm going to change the number of steps here to 4 steps. So I think that's 4. Let me count. 1, 2, 3, 4. Well, we can try it and see. Okay, so you can see we're only doing it on 2 and 4. There's nothing on 1 and 3, so it sounds like it's on 1 and 3, but it's on 2 and 4. Okay, so we can do it on 1 and 4. and so forth and so on. So this is how we can get slightly more complicated sequencers. And there's another thing you can do before, whoops, give me a second here. Before we're done with the sequencer, all these knobs, these generate a control voltage output. So this row 1 here, this is on every step, you can output a different voltage. And if you want to make a nice sequence run, like you remember those Tangerine Dream albums, where you have a little bit of this motoric repeating notes, you can program each one of these knobs to give you a different control voltage output. In fact, let me try this right now. And I'm going to take this row 1 output and I'm going to hook it into the let me see, the resonance of the filter. I hope this works. This may be a little intense. And now using these 2 knobs corresponding to these 2 things, we can change the resonance depending on the beat. Hopefully this works. Okay, we're on row 1 here. So yeah, there we go. So that second beat has a higher resonance, and you can hear the filter sweep. You can hear that resonance actually going down. Okay, well, that's a good way to get a that filter sweep is a good way to get a syndrome sound or an 808 kick if you take it down. So let's do a syndrome using that exact principle of using a filter at resonance to generate a sound. So we're going to need another envelope generator, and we're going to need another filter, but those are easy to add. So I'm going to do those right over here. Okay, let's add a filter. Where is the filter? Here we go. VCF filter, third one in on the top row. And we're going to add another envelope generator. Right click, ADSR. All right, so here I'm going to put the ADSR on the left, and I'm going to hook up the output of the ADSR to the frequency of the filter. So this is going to control the frequency. We don't need to worry about the input because we're going to turn up the resonance high enough that the filter itself is oscillating. Okay, I'm just going to hook up the trigger, the gate and the trigger to the keyboard just so I can test this now. So let me zoom out a bit. Gate to the gate, and the retrigger to the retrigger. And now I need to hook up the low pass filter to the mixer here so we can actually hear it. Low pass filter up to input 2 on the mixer. Okay, and here you can actually hear it now. So I'm going to turn down the frequency so that's a little bit lower because it's now resonating. Okay. So now if I hit a key, let me turn up the CV2 here. There we go. And I'm going to turn down the sustain because we don't need any. And turn down the release. Let's turn down the frequency. So that's now infrasonic. And there we have a little bit of a syndrome. Okay. Now, If you turn this down a little bit more, you get a lovely, lovely 808 kick sound. And on my little laptop speakers, you can't hear this, but if you're wearing headphones, it's a really lovely, resonant, big tom-tom kick sound. So if you take that thing all the way down, and you can make it last a little longer by turning down the decay, or even longer, and then going back. Okay, I'm going to keep that in the audio frequency just so people who aren't using headphones can actually hear it. If you're using a laptop speaker, that may be a little hard to hear if the frequency is too low. But plug this into a nice amplifier system and you can rattle the roof. Trust me on this. And this is good fun with an analog synthesizer and a high power amplifier and some good speakers. You can really, really annoy the neighbors. Good times. Okay, so now we have two pretty decent drum sounds. We have our snare sound, and we have our syndrome. Let's sequence them both now. So now I'm going to disconnect the keyboard that I was using to test our syndrome, and now we can hook up the gate to the output, and now this will trigger this on beat 1 and the snare drums on beat 2 and beat 4. So there we go. We got a little drum machine. I'm now going to use our little mixer here to get more beats from the syndrome. So let me zoom in a bit. Okay, so I'm going to take that gate out now, and I'm going to hook the gate from this output. And now any trigger that go into this little mixer here, now will trigger our syndrome over here. So let's just do that on 1 and 4. I'm sorry, 1 and 3, so you can see what I'm doing here. And now if I start this, we should get boom, chick, boom, chick, boom, chick. Good stuff. And we can change the frequency. Good stuff. If you want a little bit more syncopation, let's go down to all 8 beats. And now we can, let's do, so if this is a bar with 4 beats and this is a second bar with 4 beats, on the second bar, let's do syndrome on first and second beats and the snare on the third. Okay, and here we go. Good times. And now we can mix the various drum sounds using our mixer. That's the snare, and this is the syndrome. Okay, and the last thing I'm going to show you here is using our control voltages here to affect the resonance of the VCF here to make this a little louder or softer. Okay, so row 2 over here, the resonance, and now this is the second row here. So if you want, patch here is getting a little complicated, but we can zoom in here, and anything going to this channel 2 is our syndrome. That's on 2, and so I'm 1 and 3 here rather, so we can turn these up and get a little bit more resonance and see what that sounds like. All right, yeah, actually, to be honest, that actually doesn't change the sound very much because the resonance is so high that it's oscillating now. If I wanted to, I could mix that in with the frequency using another mixer. But I think right now, that's about most of the things I wanted to show you. Hopefully this gives you an idea that this thing exists, it's in the world, how to add in, how to patch things, how to add and subtract modules. If there are any questions or anything, I can definitely take them off the chat. Okay, where did my chat go? Chat.
I don't see any questions in the chat right now.
Okay.
The one question I had before was, could you recreate the gated reverb classic sound of the 80s, like from In the Air Tonight and things like that? Is there a way to do a something like that? And bearing in mind that I have no idea how it was originally done for Phil Collins drums or anything like that, but I just thought, you know, when I saw the term gates in the sequencer, it made me think of gated reverb.
Absolutely. That's a great question. That's a great question. And that would be easy to do, except right now I'm only using the stock modules. What you need is a reverb. And right now there is not, if you scroll down here, there is not a reverb in the stock modules. There are probably lots of reverbs. If you sign in to the VCV Rack site, you can get all kinds of modules. Some of them you have to pay for. You definitely use a reverb. And then what you do is after the reverb, you put that into a voltage controlled amplifier with an envelope generator. So you give it a long tail reverb and then you just cut it off when you want to. In fact, we got a little bit of time left, so I can actually try and simulate that using our delay. Okay, so let me see if I can do that. What's the easiest way to do this? Let me think. Boy, thinking on my feet. Okay, yeah, let's just do the things we used to do. So there we go. And that was a good tip in the chat. If you hit control, you can drag whole groups of modules around. Let's just hook this up. And I'm winging it here, so thanks for sticking out. But let's try and do a gated reverb, because that's a great thing to demonstrate how to do. Okay, so what we're going to need a gate. And we're going to need a let me think. Okay, I think I got an idea how to do this. Let's just use the VCA in the mixer as the gate. And that will be run by an ADSR. And then we will just stick in a delay between the snare and the mixer, and that will give us our reverb. Okay, so let's do that right now. Let's put in a delay. Where did they hide the delay? I should know where these things are by now, but I don't. There we go. Delay. Okay, so from the output of the filter here, which is now going into the to the mixer, let's just put that into the delay and patch the delay into the output. So now you can hear there's a little bit of delay on the snare drum sound. Let me turn the snare drum sound up, and let me turn down that annoying syndrome. So now all we get is a snare drum with a little bit of delay. So what I'm going to do to kind of simulate a reverb is I'm going to turn the feedback up, and I'm going to turn down the delay time a lot. Okay, and let's see what that sounds like. Yeah, that's not as quite as good as a reverb, but we don't have a reverb here to work with, so delay is what we got. So the feedback is how much the output is fed back into the delay. So if you turn that up, you get a longer tail, and I have a short delay time to simulate a reverb. So that's kind of ugly and colored, but that's what we got. So now let's put another envelope generator, and this is going to control our gate. Okay, ADSR. And okay, so now instead of the ADSR here controlling the output, this one's going to do it. Right now, this is just controlling our filter sweep. So we're using this ADSR, controlling the amplifier, the level. So now we should be able to trigger this with our ADSR, and we'll use the decay to give us our gate. So the same thing that's triggering our snare drum here, which I think was this one, yeah. So I'm just going to duplicate this control and send that to the gate here. So now this is going to be a little bit crude because what you want is the gate to hang on for a little bit, then snap off immediately. And we've only got, I need to stretch that pulse to get the actual gate. So I'm just going to use the decay here to try and do something like that. So take down the attack completely and maybe take down the decay and see what we can do here. This is completely winging it here, so we'll see what we got. I'm going to take down the clock too, so it's a little slower. Yeah, this is not very convincing. I apologize. Yeah, I think what I need to do is actually get an actual gate that lasts. Actually, that lasts for a different amount of time, so we can change that independently, and here it actually cut off the reverb. All right. Yeah, that was not convincing. I apologize. Anyway, I feel like we're kind of getting to the end of the things I wanted to show. We can probably end it pretty soon. People want to hang out and ask questions, or people want to move on to other things. That is totally cool. And once again, I want to, I'm just going to show my lovely face again for a moment. Thanks again, everybody, for joining me. This was fun. It was great to see everybody. I hope you got a little bit out of this. Lots of listening to me drone on and throw patch cables. It's VCV Rack is free. It does a pretty good job of doing the things an analog synthesizer would do. If you feel like splashing out and spending money on actual analog synthesizer modules, once you master stuff on VCV Rack, I think you're in a lot better place to know what you like and what you don't like and what you want to use. One of the things I cannot do is give you recommendations of synthesizer modules to buy, because I don't actually know. My personal synthesizer is from the 80s, and I don't think they even make it anymore. I did mention Polyphony. VCV Rack will support a lot of the modules, will support Polyphony. I actually haven't used it that much, so you need to explore that a little bit yourself. And that probably needs a MIDI keyboard as an input to actually get polyphonic note information into the program, because I don't think the computer keyboard will do that. All right, somebody in the chat says they have a MIDI controller plugged in and it's working great. That is awesome. A lot of the modules will support polyphony using that one patch cord, which is a magic thing you can never do in the analog world. There are definitely reverb modules for Rack. I have not looked at them in a while. The way Rack works is to get the full spectrum of the modules that are available, and there are hundreds of them, and a lot of them are cool. What you need to do is make an account at VCV Rack. Not everything is free. Some of the modules are paid modules, and you pay money for them. You pay money to the developer, and that helps the developer develop cool stuff. There are a lot of free modules. Pretty sure there's a free reverb there. I need to go take a look and see what's there. I apologize, I don't know off the top of my head. Hackaday, can we do this again in a few months? I'm certainly game.
Yeah, maybe I can convince you to do a hack chat with us one of these Wednesdays coming up.
Oh, I'd love to. I'd love to. In fact, I think one of the things I'd really like to do is an introduction to Fourier transforms and the frequency domain using some of the code here and some of the principles here, because I think thinking about the music and the audio, how things work in the music and the audio domain is a great way to really get a intuitive feeling for what's going on in the frequency domain, and something that you don't get just by cranking out Fourier transforms or looking at your spectrum analyzer. So one of the things that's on my list is to actually hack a little spectrum analyzer into that scope module, because it is open source, and that would be a fun thing to do. So you can see that peak that I showed you in the filter, how that would move around as you change the filter frequency, or being able to pick out the harmonics, see how the harmonics change of the different waveforms.
Yeah, that was actually one of my first questions when I saw the scope. I was like, well, where's the spectrum analyzer? There's got to be one, right?
Exactly, exactly. Yep. Worse than that. All right. I think we can end it here. I want to thank everybody for joining me. You can, if you have questions you want to take offline, I put the slides and the info in the Hackaday chat. I will save the patches I did in the first and the second parts. I will save those and I will put those online if you want to upload them and play with them or see how I did things. And thanks again for joining me. Thanks to Hackaday people. Thanks to Sophie and Mike, and thanks Dan for writing shotgun on the Zoom controls. And signing out from San Francisco. Thanks, everybody.